Hello everyone and welcome to our lesson on number theory. We are still on linear Diphantine equation and in today's lesson we are moving on to the one that involves three variables. Linear Diphantine equation involving three variables. In our previous lesson we look at the one that involves two variables. And in today we are moving to the ones that involves what? Three variables. The three variables is more or less similar to the two variables. We are going to follow some few approaches from the two variables and then we add in some small ingredients to it. Solving linear differential equation involving three variables as easy as ABC. So let's look at these two examples on the board. Let's start with the first one. So with the one that involves two variables, the first thing that we normally do is to find the GCD of the two integers and then we check to see if it divides D or it divides this. If it divides that, then it means it has many integral solutions. If it does not divide, that means that equation has no solution. So we are going to follow the same approach from there. So we have 5, 15, and 20. We are going to find the GCD of 5, 15, and then 20 to see if it is going to divide what? 1. If it divides 1, that means this equation has a solution. If it doesn't divide, it means it has no solution. So with this, we have the GCD of 5, 15, and then 20 is what? 5. So these are GCD. Now, does it divide 1? Does 5 divide 1? You can see that 5 does not divide 1. So it means that this equation has no solution. Then we end there. Now let's look at this particular example to see if it actually has a solution or not. If it has a solution, then we continue to solve it. If it doesn't have, then we end there. So first thing, we find the GCD of 35, 55, and then what? 77. So we have our GCD of 35, 55, and then 77. And we know that the GCD of these three integers is what? 1. Now does 1 divide 1? And it is true that 1 divide 1. So it means that this equation has what? Has many integral solutions. Now, if it has a solution, how do we approach it? How do we approach a linear differential equation involving three variables? We have two methods. We have the split method and then the substitution method. We are going to make use of what? The split method. So with the split method, we are going to have our first 35x. Then we are going to split this into 2. Now we know that 11 can divide 55 and 11 can divide what? 77. So we can factorize 11 out. So we are going to have 11, then we have what? 5y plus what? 7z. And this is equal to what? 1. Now once we read this well, we let what is inside the bracket be equal to any variable at all. Let's say w. And that w must come from the set of what? Integers. So we let 5y plus 7z be equal to w, and w must come from the set of what? Integers. And then we come and pick the next one, which is 35x plus 11. We are saying that the whole of this is equal to w. So we have 11w is equal to what? 1. So let's call this equation 2, and then let's call this equation 1. Now from equation 1, we have 5y plus 7z is equal to w. Now we can equate that w to 1. We can equate w to 1 because 1 is a factor of every number. So once we get our values, we multiply by w and it is going to actually work. So we are going to have 5y plus 7z be equal to 1. So the answer that we are going to get, we are going to multiply by w because at the initial state, We are saying that the whole of this is equal to W. But we are equating it to 1 because 1 is a factor of every number. So the answers that we are going to get will multiply by what? W. Very, very easy. Easy and then simple. So once we have this, then we find the value of y and then c. This is a linear differential equation involving two variables. So we go through the normal approach. Using the Euclidean algorithm, we can find our y and then we can find what? Our z. So using Euclidean algorithm, we have 7 is equal to what? 5. Then how many times of 5 divided 7? We have 1. We have a remainder of 2. Then we have 5 is equal to 2. 5 divided by 2 gives us what? 2. We have a remainder of 1. Then these two come. Then we have 1. 1 times 2 will give us 2. We have a remainder of what? 0. So once you read this 12 points, they will move backwards step by step. You do what? You move backwards step by step. So this implies that our 1 is equal to 5 minus 2, 2. They come to this side. This implies that our 2 is equal to 7 minus 1, 5. So let's start from 1. So we have 1 equals 5 minus 2, 2. Now this 2 here means that wherever we see 2, we can plug in the whole of this. Because we are saying that 2 is equal to this. And we have 2 in the bracket here. So wherever we see 2 here in the bracket here, we are going to replace it with this. So we have 5 minus 2, we have macho bracket. Then we replace it with this 7 minus 1, 5. Then we expand the bracket. We have 2 and then what? 7. Please don't multiply it to get 14. Just put this one in the bracket. Then 2 times 1 give us what? Positive 2. Negative negative 4. And then put the 5 in the bracket. Now we have 5 and 5. When we group the lightest, we can add them. We have 2 plus 1 give us what? 3. And then we pick one of the 5. Then we have 2 and then what? 7. So realize that we are having 5y, 7z. We have 5 and then 7. Let's rearrange this to look like this. Okay. So we have, the first one is 5. So we have 5 brackets, 3y minus, so let's make it plus 7 and then minus 2. And this is equal to the GC. The GCD is 1. It's equal to 1. So once you get this, we have 3 and then negative 2 is equal to 1. So from here, we can say that our what? Our y naught is equal to 3, and then our z naught is equal to what? Minus 2. So this is the particular solution. Let's look at the general solution. So the general solution, we have our y is equal to y naught plus what? Plus dt all over what? The GCD, where t comes from the set of what? Integers. And then our z is equal to z naught minus at all over the GCD, where t comes from what? The set of what? Integers. So when we plug in, we are going to have our y to be equal to y naught is what? 3 plus our b is the coefficient of what? Z. So we have 70. The GCD is 1, so all over 1. And then we have our z to be equal to z naught is what? Minus 2 minus a is the coefficient of what? Y. So we have 5t all over the GCD, which is 1. So the GCD is over 1, and that is that. So this becomes what? The general solution for y, and then the general solution for what? Z. But realize that the initial equation was 5y plus 7z is equal to w. And we equated it to what? 1. So the answer that we are going to get, we are going to multiply it by what? W. So our y is equal to w multiplying what? 3 plus 17. And then our z is equal to w times what? Minus 2 minus 5t. So this is what? The general solution for y, and then the general solution for what? Z. Now once you have y and z, we search for what? X. And we can obtain x from here. You can obtain x and then w from equation 2. So we are going to move straight to equation 2. So we have from equation 2, we have 35 w plus 11, 35x, sorry, plus 11w is equal to what? 1. So with this one, we are going to find the value of x and then z using the linear Diphantine equation involving two variables. So we are going to use the Euclidean algorithm to find what? Our x and then our z. So we have 35, then 11. 11 divided by 35 will give us 3. We have a remainder of what? 2. Then we have 11, then the 2. 2 divided by 11 will give us what? 5. We have a remainder of what? 1. Then the 2 will come, the 1 will come. 1, we have 2. 2 times 1 will give us 2. We have a remainder of what? 0. Since we are getting 0 as our remainder, we end there, and then 1 becomes what? Our GCD of 35 and then what? 11. So from here, we are going to move backwards step by step. This implies that 1 is equal to what? 11 minus 5, 2. 11 minus what? 5, 2. Then we have this implies that 2 is equal to 35 minus 3, 11. So we are starting from the bottom. We have 1 is equal to 11 minus 5 or 2. Now this means that wherever we see 2 in the bracket here, we are going to plug in the whole of this because we are saying that 2 is equal to this. So wherever we see 2 here, we are plugging in the whole of this. So we have 11 minus 5, 35 minus 3 what? 11. So we have 11 minus, we expand to move the bracket. This is going to give us 5, 35, and then we have negative will give us 4, 5 times 3 will give us what? 15, and then what? 11. So from here you can see that we have 11, 11, 11, 11. We are going to group the items and then we add. You know how to go about it because we've already looked at several examples on this. So this is going to give us what? 16, 16 what? 11 minus 5 what? 35. Now once you read this one, we are going to rearrange this so that it will look like this. So 35 comes first. So we have 35 into brackets minus 5. Then we have plus 11 into bracket what? 16. And this is equal to what? The GCD, which is 1. Since the initial equation was equal to 1, we are just going to leave it like this. And then this one becomes our what? Our x naught is equal to minus 5. And this one becomes what? Our z naught. Oh, so here was supposed to be w because we have 5, where is it? 35x plus 11w. So here is supposed to be w, not z. So from here you can see that our x naught is equal to 5, and then our w naught is equal to what? 16. Now we can find the general solution. So the general solution for x is going to be x naught plus what? bt. Let's make it x because we have t here already. So bx all over what the GCD, and then our W is equal to W naught minus what AX all over what the GCD. So we have our X is equal to, our S naught is minus 5, our B is the coefficient of what? W, which is 11, all over the GCD, which is 1. So it is like this. Then we have our W is equal to W naught is 16 minus A, which is the coefficient of 35, S, so this is S, all over what? The GCD, which is 1. So it means the general solution for this equation is S is equal to this, and then W is equal to that. Now we are not done. Now that we know the value of W, we had Y, where is it? We had our Y to be W multiply this, and then we have Z is equal to W multiply this. So it means wherever we see W, we are going to replace it with 16 minus what? 35x, because that is what the actual value of W. Okay, let me write it here. So we have our final solutions for x, y, and then z. So our x is equal to minus 5 plus what? 11x. And then our y is equal to w. So w is this one. So we have 16 minus 35s multiplying this 3 plus 70. And then we have our z is equal to w. So w is what? 16 minus 35x multiplying what? Minus 2 minus what? 5t. Remember that t and s must come from what? The set of integers. So the value of x, y, and z are given as this. So any value that you pick for t and then s, it will satisfy the equation given. So let's take it that our t is 0 and then x is 0. We are going to verify to see if it's actually going to satisfy this equation. Okay, we are done. The final answers are this and that. This, this, and that. But actually, I want to verify to see if it's actually the case. So let's take it that our t is equal to 0 and then s is equal to 0. If t is equal to 0 and then s is equal to 0, this is going to give us what? Minus 5. So we have x is equal to minus 5. Now, if s is equal to 0, this will go to 0. If t is equal to 0, this will go to 0. So we have 3 times what? 16. 3 times 16 gives us what? 48. So we have y is equal to what? 48. Now z, if s is equal to 0, t is equal to 0, we are going to have t here to be 0, this to be 0. Negative 2 times 16 will give us what? Negative 32. Minus 32. When you plug it into this equation, you are actually going to get what? 1. This means that our solution is actually true. This brings us to the end of today's lesson. See you tomorrow. Bye bye.